centripetal force. Chapter 11, circular motion. Last session, we know that what is radiant and also what is a linear system and also angular system. The main equation in it should be the linkage between linear and angular motion. The equation is V is equal to R omega. In this session 11.2, we will focus on this relationship and also F is ma, Newton's second law. Now let us to start it. This one, centripetal force 向心力 ，OK， 唔係離心力，係向心力，向住中心嘅力。This one, let force in uniform circular motion. What is the meaning? It means that in order to have a circular motion, you should provide force on it. But why? Look at this. Imagine a ball moving on a camlink at a constant velocity. Then what will happen? Of course, should be a linear motion. Move it in a straight line with a constant velocity. Then what will happen? If no left force is acting on the boat continues to move at a constant velocity v. Of course, uniform v, it means that constant v, acceleration a should be 0, no left force is acting on it. But if we have the left force acting on it, for example, acting on forward direction, then the velocity of the boat will be increasing. A is non-zero. Similarly, if the force acting on it is in backward direction, reduce its velocity. Okay, this one is a deceleration. The velocity will be this, moving forward at a decreasing speed. I think all of you should understand it in linear motion in the previous chapters. How about this? In circular motion, it means that the ball will not move in a straight line. It will move in a curve along the arc length. Then what will happen? You can see that the direction of the ball will be changing. In order to change the direction, you should provide a force on it. Then look at this. If the left force acting on the sideway means that not forward, not backward, should be maybe right hand side or left hand side. The ball changes its direction of the motion but keep moving at a constant speed. A very important part, look at this, constant speed. It means that the speed is no change. Okay, keep it unchanged. But how about the direction is changing? The case will be like that, moving in a forward direction with a constant speed, for example 1 meter per second. And then, after a certain time, the ball comes to here, the speed will be the same, 1 meter per second. But are they the same? If this one is speed, they are the same. But if this one is a velocity, they are not the same. Because in this one, the direction is outward. In this one, the direction is right hand side. They are not the same velocity, but they have the same speed. How to make change in direction? You should provide force or acceleration on it. Then in order to it, you can see that the force acting on it must be sideways. Log this one. But why? If the force is acting on this, you can resolve components. One is in this way, the other one is in this way. How about this way? In this way, the effect of it is make it accelerate. Then you cannot keep the speed constant. If like that, then what will happen? The component will be this one. You will make the boat decelerate. Okay, the speed will be changing. In order to make the speed without any change, then what should you do? This one? No. This one? No. You must this one. It means that 90 degrees. If this force is make it 90 degrees, no change in the magnitude of the speed, but you can change the direction. Okay, how to change it? Look at this. You should provide a force acting on it. This force should be a constant sideways net force, okay, to make it circular motion. Once again, look at this diagram. You can see that should be in right angle. It means that this force cannot affect the speed of it, the linear speed of it. If like that, what is it? Should in the linear speed should be tangential direction. Right angle to the tangential direction should be this direction, radial direction. The radial direction should be pointing to a very special point, center of the circle. Okay, this one tells us that why the force we call it centripetal acceleration, centripetal force, 向心力，向住中心的力。Okay, and then we have this equation. F is equal to ma. F is in this way, towards the center. Then mass is a scalar, negate it. How about the acceleration? Should also be pointing towards the center of the circle. Then you can see that this one. It means that this ball has acceleration in this direction. Okay, centripetal one. But how about the speed? Will not be changed. A very strange concept. Speed is no change, but we have acceleration A. In the previous chapter, you will think that this one is wrong. But pay attention. Speed is not changing, but the direction is changing. In order to make change in direction, you also need to provide A acceleration. This acceleration we will call it centripetal acceleration. This one is the equation, but before I start it, I want to pay attention on the direction of it. And initially for this point, the speed should be in this way. It means that the ball should want to move in this way. But unfortunately, we have the sideways force, sideways acceleration. It means that this ball cannot move forward. It will move a little bit to here. Okay, then it means that this one is not the final position, should be this direction. And also, move to this way. No, to move towards the center. It means that this one, maybe here will be the center, then this object will move to here, in this direction. Okay, then what will happen? This ball cannot move straight. It will move in a curve, like that. And then after some while, this one wants to move in this way, wants to move to here, but it can't because we have the centripetal force pull it towards the center. Then the outcome may be like that. Finally, we can build up a circle. This motion we will call it circular motion. Now try to look at the formula on it. Force should be ma. Okay, and what is A? A should be this equation. This one. V square over R, or omega square R. Unfortunately, in your syllabus, the derive of it is cut. If you want to focus on it, how to prove it, you can look at your book, page 319. It will explain it a little bit. Okay? But if you want to understand it, I will mention it in the online tutorial later. Okay? But remember it, this one just an enrichment. You just need to know that what happened, how to derive it. But in our DSC syllabus, you just need to know that how to use it. You need not to prove it. Okay? To prove it, why AC should be like that. Okay? And also this formula will be given to you. This formula and this one. Okay? But the difference between it should be this relationship, the linker between linear and angular motion. Okay, try to look at this simulation. Here, show it velocity, acceleration, and force. What can you see? You can see that the velocity is changing. How about the speed without any change? How about the acceleration? Solid acceleration should be always towards the center. Once again, the acceleration and the velocity should be make an angle. This angle is 90 degrees. It means that they are independent. They will not affect each other. And we know that A times M should be the left force. The left force should be pointing towards the center. Okay? Like that. Now, next part. If I increase the angular velocity, it means that omega. Then what will happen? Try to look at it. Okay, we set it. Then you can see that the velocity should be increased. Okay, because V is equal to R omega. Omega is changing, so V should be changing. Then what will happen? You need to pay, okay, greater A and greater F to pull it. Why? You can look at that. The ball has inertia. It wants to move forward, but unfortunately, we have the centripetal force to pull it back. Okay, if you have greater V, it means that more difficult to pull it inward, okay, to the center. Then you should provide greater force. How to know that? This equation. Okay. If R is without any change, V is increased, then the force needed to pull it back to the circle should be greater. On the other hand, if omega is greater, R without any change, centripetal force is also increased. Okay, you should notice the effect on it. How about the mass? Similarly, greater mass, it means that greater inertia to have the previous motion. Then you should provide greater force on it. Okay, can you see it? Greater force. Now here, providing centripetal force. From now on, you should notice that in order to let an object to move in a circular motion, you must provide force to make it change direction. Then this force, we will call it centripetal force. But look at this. Centripetal force is not a kind of force. It means that this one is not elastic force, electromagnetic force, is not force, not the tension. Okay, centripetal force just only refers to the left force required on it. Once again, centripetal force is not a real force. Centripetal force just only a left force, the final resultant of all forces. 記住 ，centripetal force 唔係真正有嘅 force， 佢只係最終極嘅 left force， 佢必須要靠一啲真嘅 force combine 而嚟嘅，得唔得？This one is very important concept. Otherwise you are wrong. Right here, provided by any kind of force. This one should be a sideway friction. The centripetal force needed in a Form 1 racing car should be the friction. Okay, this one is one spelling. Okay, the friction. Otherwise, this formula car cannot turn or move around this circular corner. The other one should be the tension. Tension is the actual force, the real force. But in this case, the tension can provide as a centripetal force. Okay, the other one will be the normal reaction. Normal reaction is a real force, and in this time, it will provide centripetal force. Look at this. On a three-body diagram, draw only the forces that compose the centripetal force. This one means that the first diagram is a common mistake. Once again, we haven't any centripetal force or centrifugal force。嗱 centrifugal 咧改咗後邊個 pedal 變成 FUGE centrifugal 咁嗰個叫做離心力。記住係冇離心力，亦都冇向心力。向心力同離心力都唔係力。OK， 向心力只係一個終極加埋晒之後嘅 outcome 嘅答案嚟嘅啫。OK，so look at this. The left force is not the addition of the friction and centripetal force. The left force just only the friction. The left force we will have the other name centripetal force. 所以記住，向心力只係終極做完晒所有 force 加埋晒之後嘅答案，即係個 resultant 就係個 centripetal force。Okay, so in this case, the sideway force should be the friction only. This friction is large enough to make the car moving in a circle. Okay, example 3 to tell you what happened. Here on the this is rotating, and then put a block of it to give you a mass. Tied to the center of a smooth horizontal disc. Okay, by a string. It means that this one will move in a horizontal plane. This plane is smooth. Okay, and then for one cycle period will be 2 seconds. Now find the tension in the string. The tension should be large enough to make this block moving in a circle. Then apply the formula. We have 2 seconds for one revolution. Then omega should be this one. And then apply the force. Omega m omega square r. And then we can find out the tension on it should be this. You may ask that why. We have two forms. One is omega square r. The other one should be v square over r. Which one should you use? Actually, they are the same. Okay, just only change the variable omega and v. Okay, but in the later part, I will mention it, the main difference between these two. Okay, but in the later example, I will explain it. But I want to explain it now here. Will be v and omega. Which one is governed by it? Governed by the object itself or by the other external part. Okay, omega means that governed by external part. It means that in this case should be the circular disc. If this one is governed by itself, for example Form 1 racing car, we will use V. Okay, just that's all. I will explain it further a little bit later. So this one, part A, linear speed of the block. So what will happen? Using the formula, V is R rho omega. Omega should be 2 pi over T, and then substitute it in it. Then we can see that the linear speed of it should be this. And then what is the tension? Should be the other formula. Okay, you can get the same result. Okay, because they are the same. Part B, the string suddenly break while the block is moving. Then what will happen? Originally, we have the centripetal force to make this block moving in a circle. But suddenly, if this tension is disappear, then what will happen? Inertia. Keep it moving. Then what will happen? Just before the string break, the block has velocity in tangential direction. Then suddenly, if we move the tension, then this block will move in tangential direction, tangent to the circle, and then move straight. When the string break, low horizontal force acting on the block cannot change its direction. By Newton's first law, continues to move at constant speed along the tangential direction. What if question? if the angular speed of the bulk is half, it means that omega is half. Then what will happen for the tension? Of course, using the formula, this F is equal to m omega squared r. Now omega is half. Omega squared should be a quarter. Then the force should be reduced to a quarter of its original value. Okay, next one. Example 4. This, okay, molar Y, 洗衣機. In this case, what will happen? You can see that all the people will fall in mid-air, okay? But actually, it's not. They are in the roller, in a very fast speed. Then you can see that all the people will stick on the wall of the roller. I will like that, okay? And now a roller, a rider is pinned against the wall. It means that this man will stick on the wall. But why? Here, this man, when we draw the free-ball diagram, will be like that. The minimum friction between the rider and the wall should be the normal reaction of it acting on it should be this relationship. Maximum friction should be related to the normal reaction times 0.5. Usually, this one will be given to you in examination question. If the radius of the barrel is 2 meters, find the minimum angular speed of it to avoid the rider sliding down. So you should draw the free-ball diagram of it. For the rider, we have weights, but now it cannot move down because we have the friction provided on it. But this friction should be depends on the normal reaction. Then you can see that this one. Maximum friction should be related to mg, okay, because they balance it, then the rider can fall in mid-air. And how about the maximum friction and the normal reaction should be this relationship. Then afterwards, you can find out the normal reaction should be 2mg. But what is the function of this normal reaction? Should be the centripetal force. Once again, normal reaction in this case will be the sources of the centripetal force. Okay, then we can apply the centripetal force equation m omega squared r, and then substitute it. Then we can get this omega. This one explains it that if the rotation, the angular speed of the roller is less than this value, it means that it cannot provide enough normal reaction, at the same time not enough friction to balance weights. Then the rider will drop down. Okay, so this one tells us that should be fast enough. What if question? What will the minimum angular speed change if the mass of the rider increases? Before you answer this question, you may think that the rider is heavier, then more difficult to keep it here. Then you can see that may drop down easily than the lighter object. But is it? Look at this. The normal reaction should be 2mg. At the same time, normal reaction will be the sources of centripetal force. Then, using these two formula, you can find that Rm will be cancelled it. It means that independent of mass. So when you go back to this photo, you can see that they are different in weight, different in mass, but they can keep it linear the same position in mid-air. This one explains why this one is independent of mass. Okay, example 5, ferry wheel. In this case, what will happen? We have the constant angular speed omega in vertical direction like that. Name the forces acting on them. Okay, what force provides centripetal force? Of course, in this case, you should draw the free-ball diagram. This one. Okay, the force acting on it should be the normal reaction. At the same time, we have the weights. But pay attention. In this case, they are not the same. In the usual case, we will think that keep it here, this position. normal reaction should be equal to weight. We will say that balance. But in this case, not. The centripetal force is provided by the resultant of the weight and the normal reaction. And also you can look at this figure. You can see that centripetal force should be weight minus normal reaction. Okay, weight is very important. Otherwise, if they are balanced, what will happen? This one, the weight and the normal reaction are balanced, then the net force should be 0. This object or the cabinet will move forward. Okay, but now, no, move forward is wrong. This one should be circular motion, should be in here. It means that the downward force should be greater than the upward force. They are not balanced. Should be resultant. The resultant should be the difference between weight and the normal reaction. It means that minus. So look at this. And the cabinet rotates at the lowest position, feels a gain in weight, 感覺重咗. Okay, and he says he claims that the centripetal force acting on him increases. Is it true? Of course. Draw the three-ball diagram. The answer is incorrect. Centripetal force required in uniform circular motion has a constant magnitude. Okay, but in this case, normal reaction should be greater than the weight. Why? Because should have large enough to pull the cabinet move up. Okay, otherwise this one should move forward. Okay, should be large enough to pull it upward. Then you can feel that the normal reaction should be greater than the weight. 所以大家啦，玩過山車玩咩好？衝落去嘅時候，你會發覺重咗嘅，你好似有個墜咗落去嘅。咁其實唔係你重咗因為你有個 inertia 想繼續向前行，不過唔得，你一定要向上，你要轉緊呢個彎，因此要俾一個向上大啲嘅力俾你，因此你感覺到 normal reaction 勁過平時，所以你就覺得墜咗嘅好似重咗咁。So this one, normal reaction exerted by the cabinet has to balance its weight and provide centripetal force. Okay, so the resultant should be the centripetal force. Okay, then he will feel that increase in weight. Ch11.2. Okay, here, Ch11.2. A car move along the path like that. Draw the labeled arrow to show its velocity and acceleration. Remember it. This one focuses on the circular motion. If this one is under circular motion, it has centripetal acceleration. So your answer should be like that. Okay. For the blue one will be the velocity v. It means that should be the instantaneous velocity, show it direction. But when it change the path to a circular motion, then you should provide acceleration towards the center of it. Question number 2. We have a beam, 豬仔, fall in a frictionless pipe like that. Which path will the beam take when it leaves the pipe? What will happen? When you put it in it, then it will come out. When it come out, what will happen? Is it any centripetal force? I'm not sure, but I want to explain it here. When you drop this ball here, this ball will touch the surface, the inner surface of the pipe. The inner surface of pipe will provide normal reaction, okay, to make it circular motion. So when it go to here, the same normal reaction. Here, normal reaction. But how about this? Just leave it. When it just leave it, how about the normal reaction will be absent? Then the answer should be Q, because the normal reaction just it leaves the inner surface of the pie. Okay, the force will be disappear. Only inertia. Keep the inertia. Keep it moving in forward direction. So the answer should be Q. How about the third one? Motorcycle, 電單車. Give it mass, give it speed, and also radius. Find out the centripetal force. Pick out the useful information, the useful formula, and then substitute it. Should be mv squared over r. M, you know it, v know it, r know it. Then you can see that should be 4,500 Newton to make it move in circle. Okay, this force actually is very large, but how to provide it? What force provide the centripetal force? Of course, should be the friction from the wall. Okay, the diagram may be like that. This one will be the motorcycle. This one should be the ground. The friction should be here, towards the center of the circular motion. This one should be the friction, large enough to do it. Otherwise, this motorcycle cannot make this circle. 會 slide out 線態線咗出外圈。Here, if the motorcycle turn around the roundabout 迴旋處 at twice the speed 高速轉迴旋處 what would the centripetal force require to change? 高速轉難啲轉容易線態。So look at this, substitute it. Then you can see that the friction need will be 4 times than before. 即係難啲轉彎嘅，所以高速轉彎好難嘅，好易線態。因為地下provide唔到足夠嘅 friction， 令到佢可以轉到正常嘅圈。OK， Okay, look at this. Here we have you can watch the video. Look at this. Here, make it in high speed. This bottle can provide normal reaction. The normal reaction is large enough to make the ball moving in a circular motion. How about this? This one is very difficult to do it. But why? You can see that the surface, the inner surface of it is not perfect. You can see that the inner surface should be inclined 傾斜 to a certain angle. To provide the normal reaction is not horizontal, should be inclined in this way. Okay, if in this way, you can provide 2 components. One is this one. Provide this. Right. Should be this way. Normal reaction. Okay, and here you can provide 2 direction. One is the vertical component. The other one should be the horizontal component. The horizontal component can provide centripetal force, Fc. Okay? And the vertical one can balance the weight W. Okay? But how about in the later case? This one. What will happen? You can see that the surface is not good. The surface is a straight line. The normal reaction should be in this way. You can't see, okay? In this way, you can't see any vertical components to balance W. So this one very impossible, okay? impossible to get it, okay, to balance it, to balance the weight. This one is impossible. Okay, next one, NASA.
That's the ground wave.
Okay, this one is the channeling of the NASA. Inside the roller.
Coming down.
Okay, in a fast rate, it means that great omega. And also the radius is not small. V is equal to R omega. V is quite large. Okay, this one is the channeling, and also to get the reading from the people. Okay, to measure the acceleration of them. Okay, that's all for this part.